All right, guys, so this is going to be the review for your Chapter 4, 1 to 4.3 test. The first questions, obviously, we're identifying the triangles by angles and sides. So remember, angles, acute, obtuse, right, and then we have the special equiangular. So if it's equiangular, you have to say equiangular, not acute. For sides, we just have three options. They are scalene, isosceles, and equilateral. So the first one, since these two angles are given, the last angle is 65 degrees. Since we have three different angles, the triangle is scalene. Since we have three angles under 90, this triangle is acute. Here, 25 and 130, we can get that last angle of 25. So when we have two of the same angles, that means opposite sides are congruent. So that means it's isosceles. Okay, and then 130, a 130 degree angle means obviously you have an obtuse triangle. So that becomes obtuse isosceles. Here we have 60 degrees and these two angles have to be equal, but they have to equal 120. So that has to be 60, that has to be 60. And all three sides, opposite congruent angles have to be equal. So while these two sides are congruent, so does this third side. So this is acute or equiangular. I'd prefer you write equiangular though, and equilateral, all three sides are equal. And finally, 48 and 42 is 90, and 90 plus 90 is 180, so we have a right triangle. I put the square there, and three different measure angles, so it's right scalene. Identifying angles off the graph. I happen to use Pythagorean theorem, but you could have used distance formula as well. Here I go up 6 over 4. So 6 squared plus 4 squared is 52. The square root of 52 is 2 root 3. So AC is 2 root 3. Write 3 down 2. 3 squared plus 2 squared is 13. And the square root of 13 is root 13. That's the length of AB. CB, we go right 7 up 4. 7 squared plus 4 squared is 65. And the square root of 65 is the length of CB. So we have three different lengths. Makes it scalene. Since we have two slopes that are opposite reciprocal, up 6 over 4, which is 3 halves, up 2 left 3, which is negative 2/3, opposite reciprocal slopes represent right angles. So therefore, we have a right scalene triangle. The bottom one, we have a distance of up 3 over 4. 3 squared plus 4 squared equals 5 squared. So this DF length is 5. 3 squared plus 4 squared, we get another 5. These 3 squared plus 4 squared equals 5 squared, so the square root of 5 squared is 5, so DE is 5. So these two are equal, and I can just count here for a straight line. 1, 2, 3, 4, 5, 6. So therefore, it is a distance of 6. So two congruent sides, it's isosceles. The slopes here are 3/4, negative 3/4, and undefined. There's no opposite reciprocals, so they're not right angles. So how do we know whether it's acute or obtuse? Here's the hint. 5 squared plus 5 squared is bigger than 6 squared. If you square the two smaller sides and it's bigger than the square of the third side, it's acute. If you square the two smaller sides and it's less than the square of the third side, it's obtuse. Next one, we're solving for x and y. First thing I'm going to do is I'm going to solve for x. I'm going to set all three angles equal to 180, and then I'm going to solve for my x, which is 5. Here's all the work right here. I plug the 5 in, I get 24 degrees here, 116 degrees here, and 40 degrees here. To get my y's, these two y's, remote interior angles, have to equal 116. The two remote equal the exterior angles. So 7y plus 7 plus 4y plus 10 equals 116. And my y ends up equaling 9. So I get 46 degrees here and 70 degrees here. And think about that. That would make this angle 64 degrees. 64, 70, and 46 is 180, and 64 and 116 is 180. The bottom one here, we're solving for x. We add the three angles up. 3x minus 1 plus 10x plus 2 plus 4x minus 8 equals 180. 17x minus 7 equals 180. We add 7 to both sides. 17x equals 187. And I divide 17 on both sides. We get x equals 11. And I plug my 11 in. I get 32, 112, and 36. This has to be a linear pair, or it's got to be equal to this sum. However you swing it, it's going to be 144 degrees. Or I can just do 15y plus 9 plus 36, which is this angle right here, which we figured out with the x, and we know together that's a linear pair. 15y plus 45 equals 180, We divide 15 on both sides, and our y equals 9. When I'm given a congruent figure, I'm just using the congruent statement to match up the sides. So if I want to solve for w first, c goes with h. So 5w plus 10 equals 100. 5w equals 90. W equals 18. My angle E goes with my angle J. So 15x minus 46 equals 10x plus 14. We get 5x equals 60 and my x equals 12. For my Y, GF goes along with BA. So 7y minus 1 equals 20. 7y equals 21, y equals 3. And finally, for the Z, DC goes along with HI. So my HI is 7z minus 15. 7z minus 15 equals 5z minus 1. 2z equals 14, and my z equals 7. When I have congruent triangles, angle A and angle D have to be equal, and they are. Angle B and angle E have to be equal. 5x minus 3 has to equal this angle E, and angle C has to equal angle F. So 12y minus 5 equals 10y plus 3. My y equals 4. We plug it back in, get 43-degree angles, which means angle B and angle E have to be 72 degrees. 5x minus 3 equals 72. 5x equals 75, and my x is 15. Congruency statements, I'm just matching up the congruent angles. A, 3 tick marks. B, 2 tick marks. D, 1 tick mark. Is going to be congruent to C, 3 tick marks. D, 2 tick marks. And B, 1 tick mark. Or you can do sides. ABD, 2 tick marks, shared, 1 tick mark. CDB, 2 tick marks, shared, 1 tick mark. Same thing with a four-sided figure, ABCD, 130, 110, 70, 50. 130, 110, 70, 50. So EFGH. Or ABCD, 3, 1, 4, 2. Same thing up here. 3, 1, 4, 2. The same order. Here, ABC is equal to DEF, which means I can set up a system. My A equals D. So 4x plus 3 equals 3x plus 2. My B equals E. 10x plus 2 equals 8y minus 6. We move the 8y and the 3y over. We move the constants over, and we get 10x minus 8y minus 8. 4x minus 3y equals negative 1. And then we solve the system. I multiply the top by 2, the bottom by negative 5. It eliminates my x, and I get y equals 11. When I plug 11 in, I end up with x equals 8. So you're just solving your system. And we could get angle 3 here if we wanted to, or angle C and angle F if we wanted to as well. Here, same deal with the sides. AC matches up with DF. So 5x plus 1 equals 3y plus 4. BC matches up with EF. 7x minus 1 equals 6y minus 4. I move the y's over. I move the constants over. If I multiply the top by negative 2, it allows me to get rid of my y's. Negative 3x equals negative 9. X equals 3. And when you plug back in, your y equals 4. And that's your review for chapter 4.1 to 4.3.